This is lesson 3 of our topic, geometric sequence. And this is all about arithmetic sequence versus geometric sequence. In this lesson, you will be able to differentiate a geometric sequence from an arithmetic sequence. Let us take this example. Given 6, negative 30, 150, negative 750. Let's identify if it is arithmetic or geometric sequence. To solve whether the given sequence is an arithmetic or geometric, we need to check both the common difference and the common ratio of the given sequence. Whichever solution gives us a constant answer, that is how we can conclude what sequence it is. Let's start with the common difference. Remember, for us to solve the D, we need to subtract any term other than the first term to its preceding term or to the term before it. Let's take negative 30 minus 6, where negative 30 is the second term and negative 6 is the term before it. The difference is negative 36. In order for us to prove that this sequence is an arithmetic sequence, we need to solve the D to the other terms in the sequence. Let us solve one more and we will try 150 minus negative 30. That is equal to 120. Now since both answers vary, for sure that this sequence is not an arithmetic sequence. But we still need to prove also if this sequence is geometric. So we need to solve for the common ratio, the R. And to find the R, we need to divide any term to the term before it. So let's have the same values we did in the D. So negative 30 divided by 6, and that is negative 5. Then let's solve the other one. 150 divided by negative 30, and that is negative 5. And by looking at it, both answers are the same. So we can conclude that this sequence is a geometric sequence. Let us have the second example. We have 1/5, 3/5, 9/5, 27/5, and 81/5. Is it an arithmetic or geometric? So again, to answer the question, we will check for both the common difference and the common ratio. Let's start with using 3/5 minus 1/5. Now since both fractions have a common denominator, we can solve the difference right away, and that is 2/5. Then let's do the other terms. We say 9/5 minus 3/5, and the difference is 4/5. So by looking at the answers, we can say that this sequence is not an arithmetic sequence. Now let's solve the common ratio to see if they have a common answer. Still using the same values, 3/5 divided by 1/5. In dividing fraction, you can cross multiply the fractions, or you can get first the reciprocal of the second fraction and multiply numerator to numerator and denominator to denominator. Still, they will get the same result, and that is 15/5. To simplify your answer, it will be 3. Let's do the other one if we get the same answer. 9/5 divided by 3/5. Now let's just cross multiply the values. 9 times 5, which is 45, and 5 times 3 is 15. To simplify your answer, we just need to divide 45 with 15. That is 3. And by looking at both answers, we conclude that this sequence is a geometric sequence. Let's have another example with fractions. This time the sequence have dissimilar fractions. Let's do first the common difference. Let's have 2/3 minus 1/2. To do this, since their denominators are different, we need to find their LCD, or the least common denominator. And to do this, we need to get the multiples of each number, the 3 and the 2, and the common number is 6. So 6 is our LCD. Then let's find both numerator by dividing the LCD to its denominator and multiply to its numerator. So 6 divided by 3 is 2, times 2 is 4. Then 6 divided by 2 is 3, times 1 is equal to 3. Then we subtract both numerator, so we get 1 over 6. Then let's do the other terms. 5/6 minus 2/3. Again, find their LCD, and it is 6. Then get their numerator. 6 divided by 6 is 1, times 5 is 5. Then 6 divided by 3 is 2, times 2 is 4. Subtract 5 with 4, we get 1 over 6. Thus, our sequence is an arithmetic sequence. Let us just solve the common ratio, just to prove it is not geometric. So we have 2/3 divided by 1/2. Again, we cross multiply the numbers. 2 times 2, that is equal to 4. And 3 times 1, that is 3. So we have 4/3. The other terms, which is 5 over 6 divided by 2 over 3, we cross multiply. 5 times 3, that is 15. And 6 times 2, that is 12. We can simplify the fractions since both are divisible by 3. So 15 is 5 and 12 is 4. So we got 5 over 4, or 5/4. So it proved that the sequence is not geometric. For example number 4, consider the sequence. Let's check whether it is an arithmetic or geometric by solving the common difference and the ratio. Now let's solve the common difference first. We say 3 minus square root of 3. Now since 3 and square root of 3 does not have a commonality, so our final answer for this is 3 minus square root of 3. Now let's check for the other terms if we can still get the same result. Now this time, we have 3 square root of 3 minus 3. Now again, there's no common with the two numbers. So we have 3 square root of 3 minus 3. And by checking both differences, it does not have or does not arrive with the same answer. So this sequence is not an arithmetic. Now let's do the other one with our common ratio. Still using the same value. This time it's 3 divided by the square root of 3. Let's rationalize the given. That will become 3 over square root of 3. Let's multiply both sides by its denominator. And our answer will be 3 square root of 3 over square root of 9. Now since square root of 9 is a perfect square, we will have our answer as 3 square root of 3 over 3. And then we cancel both the 3 since they are divisible by itself. So we have 1. So our final answer is square root of 3. Now let's solve the other one if we get the same answer. 3 square root of 3 divided by 3. Now let's rationalize the number. And it will have 3 square root of 3 over 3. Then we just have to cancel both 3 since they are divisible by itself. So therefore, our sequence is geometric.